In this video, we will revisit linear and quadratic patterns. So first of all, we'll have a look at some linear patterns. So if we look at the pattern 3, 5, 7, 9 and so on, we notice that there's a common difference of 2. We say the first difference is 2, and that's a linear pattern. Now move on to quadratic patterns. And when we move on to quadratic or cubic patterns, it's a good idea to write them in a table. So here, the first term is 3, the second term is 5, the third term is 10, the fourth term is 18, and the fifth term is 29. And we look at the first difference. So the difference between the 3 and the 5 is 2, the 5 and the 10 is 5, between the 10 and the 18 is 8, and between the 18 and the 29 is 11. So we notice that's not constant, so it's not a linear pattern. So we look at the second difference. And the second difference between 2 and 5 is 3, between 5 and 8 is 3, and between 8 and 11 is 3. So now we notice that the second difference is a non-zero constant. In this case it's 3, but the important thing is that it's a non-zero constant, and that's what tells us that the pattern is quadratic. We will quite often be asked to find the general term of a quadratic sequence, and the general term is an squared plus bn plus c, and the important thing is that 2a is the same as the second difference. So in this case then we get a is 3 over 2. We know the first term is 3, so that means that a times 1 squared plus b times 1 plus c is equal to 3. We fill in for a, and then we tidy that up, and we get b plus c is equal to 3 over 2. So that gives us one equation. We now take the second term, and the second term was 5. That means that a times 2 squared plus b times 2 plus c is equal to 5. We substitute in again the 3 over 2 for a, and we tidy it up, and that gives us that 2b plus c is equal to minus 1. And we now have two equations, two unknowns, and we'll solve them simultaneously. So we can just take the first equation, b plus c is equal to 3 over 2, and the second equation, 2b plus c is equal to minus 1, and we just subtract, and we get b minus 2b, so minus b, c minus c is 0, and then 3 over 2 minus minus 1, 3 over 2 plus 1 is 5 over 2. So this means that b is equal to minus 5 over 2. And we just substitute that back in, of course, to b plus c is equal to 3 over 2. In other words, minus 5 over 2 plus c is equal to 3 over 2, which gives us c is equal to 3 over 2 plus 5 over 2, which is 8 over 2, which is 4. And put them all together, and we get our general term Tn is equal to, well, a was 3 over 2, so 3 over 2 n squared minus 5 over 2 times n plus 4 is the general term of the quadratic sequence. Now I want you to try this question, but I'm going to make a couple of changes with it. So we're given the general term, and we're given the first 5 terms. You've defined the second differences are constant. You've defined the value of the constant. But then I want you to use that second difference to find the value of a. Remember that the second difference is 2 times the value of a. So you find the value of a, and then you can just use the first two terms of the sequence and write them in terms of B and C. And then you form two simultaneous equations in B and C, solve them to find B and C, and that will allow you to find the general term, and then you find the 30th term.